Imagine standing at the edge of the ocean, staring out at water that looks exactly like water anywhere else on Earth, and knowing that beneath that calm surface lies one of the most talked about mysteries in modern history. No warning signs, no strange currents visible from shore, nothing to suggest that ships and planes have vanished here without a trace. And yet for decades, scientists, sailors, and conspiracy theorists alike have been trying to answer one question. What is actually happening in the Bermuda Triangle? Recent research has started to peel back the layers of legend, and what's underneath might surprise you more than any alien abduction story ever could. For most of the 20th century, the Bermuda Triangle existed as a kind of open wound in the public imagination. It was a place where the normal rules didn't seem to apply, where compasses spun without explanation, and entire flight squadrons disappeared into thin air. The stories were terrifying precisely because they resisted explanation. But science doesn't like unanswered questions. And over the past several years, researchers from multiple fields have quietly been assembling a very different picture of this stretch of ocean, one built on data rather than folklore. To understand what scientists are finding now, it helps to remember how this mystery took root in the first place. The region sits in the North Atlantic, loosely bordered by the coastlines of Florida, Bermuda, and Puerto Rico, though its exact boundaries were never formally defined by any government or scientific body. That vagueness alone should raise an eyebrow. A location without fixed borders means that any incident anywhere in that general vicinity of the ocean can be folded into the legend, inflating the numbers and the drama. Still, the incidents that fed the myth were real enough to capture imaginations. A naval cargo ship carrying hundreds of crew members vanished in 1918 without ever sending a distress signal. A squadron of Navy bombers got disoriented during a training exercise in 1945 and never made it home. Passenger planes disappeared in the years that followed. Each event, taken alone, might have faded into maritime history. Stacked together and given a catchy name in a 1964 magazine article, they became something else entirely. A permanent fixture of pop culture, amplified further by best-selling books in the 1970s that leaned heavily into theories involving lost civilizations, portals to other dimensions, and extraterrestrial interference. What's changed in recent years is the sheer amount of data now available to researchers. Data that simply didn't exist when those early books and articles were shaping public perception. Modern shipping records, aviation databases, and satellite tracking allow scientists to compare the Bermuda Triangle against other ocean regions with a level of precision that was impossible 50 years ago. And the emerging picture is not one of a cursed patch of sea, but of a place that behaves exactly the way you'd expect a busy, storm-prone shipping corridor to behave. One of the most significant findings involves marine casualty data spanning several decades. When researchers pulled records covering tens of thousands of maritime incidents across the globe and isolated those that occurred within the loosely defined Bermuda Triangle boundaries, the region accounted for only a small single-digit percentage of total incidents. That's a strikingly unremarkable number for a place with such an outsized reputation. Even more telling, when analysts look specifically for incidents classified as unexplained disappearances within a multi-decade window, they found none originating from the triangle. Not zero because the data was hidden or suppressed, but zero because ships that get into trouble, they tend to get into trouble in explainable ways, capsizing in storms, running into mechanical failure, or drifting off course. The same categories of incidents that happen in shipping lanes everywhere else in the world. Shipping industry data tells a similar story. When analysts examined a full year of global vessel traffic and compared casualty rates for ships passing through the triangle against the worldwide average, the triangle actually came out safer, not more dangerous. Insurance underwriters, who have every financial incentive to identify genuinely hazardous shipping routes, don't charge elevated premiums for vessels transiting the area. If there were a statistically significant elevated risk, it would show up first in insurance pricing, and it simply doesn't. So if the numbers don't support the idea of a uniquely cursed region, what actually explains the individual incidents that did happen? This is where the more recent scientific work gets genuinely interesting, because it turns out there are several overlapping, entirely natural explanations that, when combined, account for nearly everything attributed to the Bermuda Triangle. The first and most consistently cited factor is weather. This stretch of ocean sits directly in the path of the Atlantic hurricane corridor. Tropical storms and hurricanes regularly track through or near this region, and they always have. Before satellite forecasting existed, sailors and pilots had little to no warning that a storm system was forming until they were already inside it. A ship or plane caught in a sudden hurricane in the middle of the ocean, decades before modern tracking, had a real chance of being lost with no distress call and no wreckage ever recovered, not because of anything supernatural, but because violent storms at sea are simply capable of destroying vessels completely and scattering debris across enormous distances, often in waters too deep for any effective search. Closely tied to the weather explanation is the Gulf Stream, the powerful ocean current that runs along the western edge of the region. This is not a gentle current. It moves fast enough to be genuinely hazardous for boats caught unaware, especially smaller vessels or less experienced sailors who fail to properly account for it. A boat that loses engine power in the Gulf Stream can be carried a significant distance from its last known position in a relatively short time. That matters enormously for search and rescue operations, because searchers looking for a missing vessel near its last reported coordinates may be looking hundreds of miles from where that vessel actually ended up. It's not that the ship vanished into another dimension. It's that ocean currents moved it somewhere search teams weren't looking, and the wreckage, if any survived, was never found in the area everyone assumed to check. Then there's the compass issue, which is one of the oldest pieces of Bermuda Triangle folklore and also one of the most misunderstood. It's true that this region is one of a small number of places on Earth where, at certain points in history, a compass needle has pointed toward true geographic north rather than magnetic north, a phenomenon tied to what's called magnetic declination. This happens because Earth's magnetic field isn't perfectly aligned with its rotational axis, and the line where the two align, known as the agonic line, slowly shifts over time. Early sailors navigating without modern instruments could genuinely be thrown off course if they failed to correct for this discrepancy. And there's reasonable evidence that this contributed to some historical navigation errors in the region, including possibly affecting early transatlantic voyages centuries ago. However, modern navigators have accounted for magnetic declination for a very long time, and the agonic line itself has actually drifted out of the traditional triangle boundaries over the past several decades, meaning this explanation, while historically relevant, doesn't hold up as a modern cause of ongoing incidents. Human error remains one of the most consistently underrated explanations, and it's one that modern researchers keep returning to. When investigators went back and studied the full radio transcripts from the most famous aviation disappearance connected to this region, the pattern that emerges isn't mysterious at all. The lead pilot became convinced his instruments were malfunctioning and believed he was in a completely different location than he actually was. Instead of correcting course based on standard navigation procedure, he continued flying deeper into open ocean, compounding the error until the aircraft ran out of fuel. Investigators have since noted that this wasn't the first time that particular pilot had experienced disorientation issues during flight. Tragic as it was, it fits a pattern seen in aviation incidents worldwide, a small initial error, compounded by stress and poor visibility, spiraling into a fatal outcome. It requires no monsters, no vortexes, and no missing science, just the very human tendency to trust a wrong assumption a little too long. Perhaps the most scientifically exciting development in recent years involves the ocean floor itself. Researchers studying seabeds in other parts of the world, including areas off the coast of Norway, discovered massive craters, some of them enormous, gouged into the sediment. These craters appear to have been formed by sudden, explosive releases of methane gas that had been trapped beneath the seafloor for thousands of years. When pressure builds sufficiently, that gas can erupt upward in a violent burst. The scientists who discovered these craters were careful to note that their research wasn't specifically about the Bermuda Triangle, but the implications were too tempting for other researchers and media outlets to ignore, and the theory spread quickly. The logic goes that if a massive methane release happened beneath a ship at sea, it could dramatically reduce the density of the water, causing a vessel to lose buoyancy and sink rapidly. And if a large enough gas cloud reached the surface, it could theoretically interfere with an aircraft's engines flying overhead. It's a genuinely fascinating geological phenomenon, and there is evidence that methane deposits do exist beneath parts of the seafloor in various ocean regions, including some areas near the traditional Bermuda Triangle boundaries. That said, scientists studying this phenomenon are careful to emphasize that direct evidence linking a specific methane eruption to any specific shipwreck in this region remains circumstantial rather than proven. It's a plausible contributing factor in rare cases, not a confirmed smoking gun. Taken together, these explanations, hurricanes and tropical storms, the sheer force of the Gulf Stream, historical navigation errors tied to magnetic declination, ordinary human mistakes under pressure, and the geological possibility of methane releases from the seafloor paint a picture of a region that is genuinely challenging to navigate, but not supernaturally so. It's a place where the ordinary hazards of open ocean travel are simply concentrated a bit more than average, thanks to its weather patterns and its position along a major shipping and flight corridor. When you combine heavy traffic with genuinely difficult natural conditions, you're statistically going to get more incidents than you would in a calm, quiet backwater, even if the per capita risk to any individual ship or plane isn't actually elevated at all. What's remarkable, when you step back and look at the totality of the modern data, is how unremarkable the region turns out to be. It doesn't rank among the most dangerous stretches of ocean in the world for shipping. Regions like the waters around Southeast Asia and parts of the Mediterranean see substantially higher rates of maritime incidents. Aviation safety records show a similar pattern, with a vast majority of incidents connected to this area occurring during routine takeoffs and landings rather than in flight over open water, the same pattern you'd expect to see anywhere in the world, since takeoff and landing are statistically the riskiest phases of any flight regardless of location. None of this is to say that nothing has ever gone wrong here, because clearly things have. Ships have sunk, planes have gone down, and lives have tragically been lost. But the scientific consensus that has solidified in recent years is that these losses can be explained through the same combination of weather, current, mechanical failure, and human error that explains maritime and aviation incidents anywhere else on the planet. The mystery was never really about the ocean itself. It was about the gap between how much we understood a century ago and how dramatic that gap felt when filled with speculation instead of data. There's something almost anticlimactic about this conclusion, and that's understandable. Ghost stories are more fun than statistics, and portals to other dimensions make for a better campfire tale than magnetic declination curves. But there's also something reassuring in it. The scientists studying this region today aren't chasing monsters. They're studying real, observable phenomena, storm systems, ocean currents, seafloor geology, and using increasingly precise data to understand exactly why certain places on Earth pose more navigational challenges than others. That's not a less interesting story. In many ways, it's a more impressive one, because it shows just how much we've learned about our planet, and how many of the mysteries that once felt unsolvable are steadily being explained, not through wild speculation, but through patient, careful research. So the next time someone brings up the Bermuda Triangle, you don't have to reach for aliens or lost cities to explain it. You can simply point to hurricanes, ocean currents, old compass errors, human mistakes, and the slow, ongoing science of the seafloor. It turns out the truth was never hiding in another dimension. It was sitting in the data all along, waiting for someone to actually look.